Today we are going to learn about linear relationships unit, and we're going to begin with constant of proportionality, and we're going to begin with tables. So to find the constant of proportionality, we're going to use k equals y over x for the following tables, and if there is no constant of proportionality, we are going to write none. So let's begin with our formula of k equals see what's going on here. K equals y over x. So if you look at the table, it shows you where your y and x values are. In this case, time is your x value and numbers of songs is your y value. So to find constant proportionality, these should simplify to the same ratios. So k equals y over x for our first set right here. 2 is in the y position, and so we would write 2 over 1. And we want to see if that's equal to the next set, which is 4 over 2. And the next pair, which is 6 over 3. And the next pair, which is 8 over 4. And the final pair is 10 over 5. So if we were to simplify these, 2 over 1, or 2 divided by 1, that's in simplest form. 2 divides into itself once and into 4 twice. So those are equivalent, so we keep going. 3 divides into itself once and into 6 twice. It's equivalent, so we keep going. 4 divides into itself once and into 8 twice. It's equivalent, so we keep going. So if it was an equivalent, we could stop and we could write none. But in this case, since it's equivalent, we keep going until the end. 5 divided by 5 is 1, and 10 divided by 5 is 2. Therefore, yes, it is constant. And that would be our answer. Let's try another one. So let's look at this table. Again, we're looking at k equals y over x. Okay, so y is the second number and x is the first number. Y over x, we would write 95 over 5. And it's important that you just write all the ratios down before you get started to show that understanding of what we're doing here. 90 over 10. Our next pair would be 86 over 15. And then your final pair would be 82 over 20. Okay, so we simplify that. We say, well, 5 divided by 5 is 1, and we know that 5 goes into 95. If you don't know how many times 5 goes into 95, then you could just go over to the side and try that out and see that it goes in 19 times. So this is 19. And then 10 divided by 10 is 1, and 90 divided by 10 is 9. So we see right there, we're going to write that not equal sign. Well, I guess maybe we shouldn't write not equal. Not means not equal. Okay, and at that moment, right there, we can write none. There is no constant of proportionality here. And a proportional relationship, if we were looking at a graph, which we will learn in a couple of days, would mean that on a graph it would be a straight line. And for this particular table set, if we were to plot these points on a graph, we would not have a straight line. Okay, if there is a proportional relationship between x and y, you can describe that relationship using the equation y equals kx. The variable k is called the constant of proportionality, and it represents the constant rate of change or constant ratio between x and y. So it says that we can represent it with this equation, y equals kx. K is called the constant of proportionality, and it represents the constant rate of change. So your constant rate of change would be your K equals y over x. Just looking at this, if I were just looking at this formula right here, okay, and on the previous page we used k equals y over x. So let's say I wanted to get k by itself. I would divide it by x to get rid of x, right? And that would leave me with k equals y over x. So this would be your equation that you can use to find constant rate of change. And this would be how you would write it into an actual equation. If you're looking at your star chart, this y equals kx is what would be on your star chart. But if we know how to solve k equals y over x, that's all we need to know what to do here. Okay, so write an equation in the form of y equals kx for the following table. Well, in this case, we need to know what k is first, because y, I have lots of y's. I have a 60, 120, 180, 240, x. I can pick any of these pairs to plug into that equation if I wanted to. What I need is to find k, and what we learned is, I'm going to do it again. To get k by itself, we divide by x on both sides, and we get k equals y over x. So that's what we're going to do to find k here. So your first set would be 60 over 1 is equal to 120 over 2, and it's equal to 180 over 3, and 240 over 4. Okay, so we're seeing if these are equal. 60 over 1 is its simplest form. 2 divides into itself once and into 120 60 times. 3 divided by 3 is 1, and 180 divided by 3 is 60. 4 divided by 4 is 1, and 4 divides into 24 6 times, and then you have the 0 is 60. So yes, constant rate of change. Crack. Right here. Guess it's not there, so I'm going to write this right here. That is our constant rate of change. So yes, it's a constant of proportionality or a constant rate of change. What is the unit rate for the above? Well, remember, unit means 1, right? So we can pull that. See if my circle will work. Right here. That is what we simplified to. So the unit rate equals 60 over 1, which is, what does 60 represent? 60 represents miles, right? So 60 miles per what? What does 1 represent? 1 represent hours. 60 miles per hour. And then last one, how are the unit rate and constant rate of proportionality related? I'm going to leave this one for you to analyze. Unit rates right here, 60 over 1. Constant rate of proportionality. We took all the ratios and simplified them, and they all simplified to 60 over 1. So I want you to write down, how are the unit rate and constant rate of proportionality related? And then write down if you have any questions.